All right. Scaling features. Scaling feature. Can we proceed or I should wait? All right, so scaling feature. So remember that our last topic was feature selection, right? Now, what is scaling? As the name implies, requires setting all input features on a similar scale. Scaling is an optional feature engineering step which depends on the machine learning algorithm you want to use. Common techniques for scaling include normalization and what? Standardization. So these are the two key method or techniques we are going to learn on how to scale value. Now, in summary, what we are trying to do here is you might have a set of values whereby you want to scale them to between a particular range. So you want to scale them between 0 and 1. That is scaling. And meanwhile, these values, some of them were 40, some of them were 50, some of them were 70. Then at the end of the day, you end up what? Scaling them to a particular range. Now, just to give a proper understanding, you can see these two diagram here. So this is a graph of VCT, which is derived from the last data we selected, right? Under when we selected the 3 headings. So we are drawing this from that particular data. So this is a graph of percentage of this type of song or types of song on or against the total number of times the student listened to the song. So the same thing. Now, if you look at this, what is the difference between this? Because this one is scaled, but this one is not scaled. What can you see as the difference? This one is scaled, while this one is not scaled. What can you see as the difference? This one is what? Is this one really scattered? Look at the value. Look at the value. All the values here, they are within 0 and what? You can see, look at the original value you have here when you were not scaled. Good. Exactly. Now, many unsupervised learning techniques use distance what? Base. Now, the concept is that how are you going to scale? You're going to scale based on what? The distance. How is one variable distance from another variable? So that is going to be the basis of our scaling. So which makes scaling a required data what? Preparation step before modeling. Remember I told you that this particular topic is the last topic under what? Data prep. So the next topic we start modeling. So now, if you are not writing anything here again, if I could just go to the next, can I go to the next slide? Okay. Okay, now you can see, remember in the first slide, I highlighted the two common what techniques used in what scaling. And now the scaling is based on the distance between one variable and the other. So we are trying to, if you look at it here, look at the value here, you can see that you hardly see the variable. They are here. Look at them here. Because they are not scaled. So if they are scaled based on the distance, you can see the way they are what? Visible. Good. Now, let's look at this diagram. This is the functions that I'm going to explain. So here we are introducing different libraries. Now, but before that, in data science, I'm trying to explain what is normalization. In data science, normalization refers to the process of scaling numeric data into a standard range. So anytime you think of scaling data, you must specify the range. And the range is going to be deduced by knowing the minimum and what? The maximum. So the difference between the minimum and the maximum is what will determine your scaling. So typically, to make different features comparable and to improve performance of machine learning algorithm, that is the reason why we normalize our data. So a data set can be given to you, then you will have to prepare it. That is, you will have to scale it, either using normalization method or using a standardization method. But both of them, they are still pointing to the same direction. As you can see here, normalization transform all column to between what? 0 and what? 1. So you have scaled it now. So they will now be closer to each other. So, or between -1 and positive what? 1. So that is the best way to explain what is normalization. Now, this is typically used when the column contributions are unknown or missed. So you have a column where you have numbers that are not known. So instead, you will just scale all of them. You just, okay, all the values should be scaled between 0 and what? 1. So the essence of this is for us to have a model or a data frame that can be passed into analysis model. Now, we are looking at this data. Remember that we save our last data selection data step. We assemble 3 headings, right?
Yes.
Age and what? Number of song and the percentage, the one we're having issue with the right word to use, right?
Yes.
Now, which are these? So in other words, remember that we must have saved it as what? Model underscore what? DF subset. I don't know whether that is how. Is that how we save it? Okay, good. Now, so we are looking at this data. Look at the on scale. Look at the scale. Look at the on scale. Look at the scale. You can see that after scaling, based on between 0 and what? 1. You see that all the value under each of the column, they have been scaled to what? Between 0 and what? 1. And look at them here. So that is what we have achieved. Now, this is the formula that is behind it. If you are doing manual statistics, this is the formula that we are relieved from using this Python library. So I just brought it out in case you want to know, okay, supposing I'm not using computer, if I'm to manually calculate what we want to achieve now, this is the formula that you will have what? Consider. And if you look at this formula, you can see that what? It's talking about what? The minimum and the what? The maximum. Now, how are we achieving this with Python library? Use sklearn. So this is another library that we have not used before. In fact, from now, we'll start bringing new libraries. These are the libraries that data scientists are exposed to that just analysts does not know. Because the analysts stop at pandas, NumPy, because of how far they want to go with their data. Now, if you look at this, because we'll go to the notebook and execute all this, but I just want to explain it. Okay, now let me interpret this. Normalization with what? sklearn. So sklearn is what? A Python what? Library that houses minimal scalar. So in other words, the formula, the function for calculating mean of range of what? Value, and the function for calculating what? Maximum between what? Range of what? Value. Now that function mean mass scalar is embedded in what library? sklearn. So you must import it first before you can access what? The minimals. That is what I'm doing here. From what? sklearn dot what? Processing, import what? Minimal scalar. What is this function going to do for us? Is to calculate under each of the column the minimum value and what? The maximum what? Value. That is what it's going to do. Now here we created an object and we call that object mm. M represents what? Minimum. While the other m represents what? Maximum. Meanwhile, it's just a variable name. Your own can be anything. Okay, this one is not a defined function. It's just a variable name. Now, this variable, what are we storing in this variable? We are storing what? The whole of what? This function inside it. Which means that as we continue, anytime I call mm_, I am accessing what? This function. Now, here is another variable that is going to hold the normalized what? Data. Okay, the one you must have, scale between range of what? 0 and what? 1. Then we are equating it to what? To the, remember that here now you have this, right? So calling this, it means that what? We are indirectly what? Calling what? Min mass what? Scalar. Now this dot fit is a function that will transform, just like we are concatenating two functions. Because we are going to end up transforming what? The data, whether you like it or not. Because it changes. Look at it from here to this. What has happened here? Transformation. So what is actually transforming the data is what? This function and this function. In other words, this function is relying on what? Is built on what? This. This one calculates the minimum and what? Maximum. While this one, we change it, we substitute then in the original data. Did you get it? Yeah. Good. Now, what did you supply as data that is to transform? The name of your what? Data set. So before I leave this line, to explain one more time so that it will sink very well, this one is to calculate the minimum and the maximum of what? This set of value. In each of these columns, here, when it gets here, it will calculate what? The minimum and what? Maximum. When it gets here, the same thing. When it gets here, the same thing. That is the role of what? This. Yeah. This one is the one that will now take the value derived and substitute them. So which means that you have suddenly moved from the original data to what? Another data. Now, we have to pass in. We have to send the value to the original data. Okay? And to do that, we will now run what? PD dot what? Data frame. Then this variable, you pass it in comma to define the column, that the column in which of the data we receive what? This transform value. So this is an attribute, columns. And then what we are storing in it is what? Model underscore, then dot what? Column. Just to know that you have to come to this data and substitute the results you have gotten here into what? Each of those columns in this data frame. Is that clear? Okay, so you may not need to copy this because we're still going to do it. Let's run the code first. We're still going to ask before you copy. Now, let's go to our sheet now. So this is the first thing I'm going to do. So now let's go to our notebook. So going back to my notebook, this is the data already. So there's no point of, looking at it again. Or if I just want to look at it, but it's as if the name is slightly different. So what I'm seeing here is model underscore what? Subset, right? So no, good. So we can actually what? Substitute. So we work with the name of our own data, okay? Because then I use different heading, different data name. Now, so I will assume that we have already, okay, so let's just take it together. Looking at the data again. So I will just type model subset. Okay. Now, the next step is this. So we're going to start importing. So we'll start by importing. So we have to be writing all this because once I switch from here, I will not be coming here. We will just be applying them. So let me give us some time to copy them. So just to, you are writing the first cell That is where we are importing, just like we highlighted it in that single cell, from sklen dot processing import minimal scalar, which means you are importing what? sklen library. Then at the point where you did this, you are saving it as what? An object. And then here you are using what? Dot fit to transform the data. Now let's go back to our notebook. So in our notebook here, the first code I want to run is to import sklen. Import sklen. So I'll say from sklen sklen. Is that what I type? Yes, I think I'm correct. Dot processing import. Hmm? We have not imported a. No. We start like this. Yes, let's start like that. Let's see. We'll get the. So import minimal. It's case sensitive. Where you have capital letter M, you have to follow it. Minimas. Scalar. So I'll run that. Invalid syntax. Where did I get it wrong? Okay, yes, I do have this. So it will take some time. Of course, maybe no module name was sklen processing. Where? We as in our work. Yeah. Okay. Now the next one is the next cell. Let's create the object, which is the underscore scalar. So this one is equals to comment. Yes. The comment is that's what I was saying. Okay, let me use comment so that it's now create an object to store the minimas, scalar. Minimas scalar. So object created. Huh? Yes, MM. Yeah, double M. So one of the M is representing minimal. So it can be any name. That is not fixed. So I just use that name so that we align with what we are storing in. You don't have any results? No, you did not add a bracket somewhere. It's a function. Look at it. It's only the first one that would not add the parenthesis bracket. So now the next step will be we want to calculate. So now that you have stored the function in your object, therefore to calculate the mean and the mass of all the values in each column. So we just call the object, which is the then concatenate the transformation function, which is fits, then supply the data you are transforming, which is the model. Let me see if I have it here. Model subset. So if I run it, good. So it's going to generate this. So what it has done now is that it has calculated what the mean and mass under each of those columns. So let me wait for. I go back to my slide. This is the one we just did now. Now, here, checking for minimum in each column. We want to confirm the calculation we just did without a fit function. Checking for the calculation. This is the formula we use to check for the minimum. This is the one we use to check for the maximum. So what is the difference? You just call that object, right? Because the calculation will have been done and stored in that object. So when you call that object dot data underscore minimum and then underscore, what it's telling us is that in the first column, the minimum is what? 19. The second column, because there are 3 columns in that data set, right? In the second column, the minimum is what? 2. The third column, the minimum is what? 0. Then by the time you run the maximum, the same thing. In the first column, the maximum is what? 52. In the second column, and then the third column. So that is to confirm that we have actually what? The fit function has what? Done the calculation. So let's write, and then we will now go and implement it. Huh? Yeah, this one. Yeah, that is how it's being stored in the library. These are functions. These are sub functions under the library you are working with, which is the sklearn. Yes, it must be there. If you try without the underscore, you see the results you are looking for. So can I go to the notebook now? Hold on. Okay. Can I move? Yeah. Okay. So now, just to use comment to explain, Now to confirm if or to confirm the minimum and the maximum in each column. So I will just call the object dot data underscore mean underscore. So you can see, so based on what we have here, it's as if our value did not tally with the one I used because I used the same data. What did you get? So I'm having 0. So let me come here and check under. It's correct, have it? Okay, let's do for maximum. Let's check for maximum, and then from there we'll know. For maximum, so I'll do the same. The data objects dot data underscore mass underscore. Okay. So that is how to check. Now let's apply the calculation. So that is just like you just did individual calculation. Now we want to apply the calculation in the data set itself. From the slide I showed us before the other time, I showed us the on scale, right? And the scale. So between the on scale and the scale, that is where the transformation must have what? Taken place. So, but what we have done so far is that we are now sure that the calculation has been done. Now we want to implement the calculation in the data set. So there you are bringing another function, which is called what? Transform. So you are concatenating that function with your objects, which is currently holding what? The calculation of the mean and what? So this is what we actually make sure that the range is between 0 and what? 1, because that is the scaling. We want at the end of the day, those values in each of those columns are within 0 and 1. So now let's go there. Like I observe here, it transformed that data using what? Normalization equation with the mean and mass value. That is what you have here. Because these were not the original data or values you have under each of those columns. So why are we having this value? Because the transformation has taken place, and all those values have now been transformed between 1 and 0, which is our target for the scaling. So now let me go back to comments. Now let's apply the calculation. So to simply do that, call the object dot transform then supply your data frame, model, subsets. So if I run this, so you can see it. So this is the same array of the value. So you can see that under those columns, we now have value between the range of 1 and 0. Now, the next thing is that we have to want to combine. Another way you can do it, you can actually join two of them together, both the fit and what transform as one function. Because what I've done is that I did fit separately. I did what transform separately. So if I don't want to separate them, I can just do what my object dot what fit underscore what transform, supply the same data, you will still get the same value. So it's just like an alternative way of doing it. So if I go back to, let's say, an alternative method. So I could just do this object dot fits underscore transform. Supply the data, which is model subset. So you can see I got the same value. Now, to assemble all, you can see that code, the slide I showed us, that is where I've already what? Compiled all. What we now that we took them what? Individually. Now, we want to assemble them and pass those calculations to the main data what? Frame. Because if you check what we have here now, the headers are not mentioned. All this value will be taken and be substituted under what? This. So that instead of you having 25, you now be having what? The value you generated here. That is what we want to do now by saying to assemble all the what? Results in one cell. So this one will now take us back to where we started from. So this is the first one. So I will just copy and paste because I'm not going to write them again. Yes, I will just copy and paste. Yes, all these functions, these are the functions we have executed now, except this line. Except this line. We have not run this one. This one here. Yeah, this is what we just did now. Good. But we have not saved it as normalized data. Because at that point, we are just doing the calculation. Yes, we have not saved it in data set. So our plan is that we will save it when we are done with the calculation. So that is what we want to do now. So let me give us time to copy everything here. This is what we are copying. Yes, we have already done the analysis, but we want to substitute it. Yes. So we are saving it as normalized, right? So we are saving it as normalized. So now, like I said, now you have all the results in one cell. I will simply copy the first line because we need it. Take the whole of this. Control C. So I want all the code to be executed in one cell. Then there's also a place where I have saved the min mass in a variable. I will also take it. There is it. So I'm also taking this. Control C. And paste. Now the next one is I will just name it normalize. Normalize is equals to I will copy the last one that generated this value, Control C, paste it. Now, I will now do PD dot data frame, data frame, data frame, data frame, then supply the normalize. Normalize, then comma, then the column, because here I am supplying or substituting the calculation. So columns is equals to the data set, which is model subsets dot columns. Columns. Let me run. Good. So you can see that we have successfully scaled all the values in each of the column to between 0 and 1. So just a brief classwork from this data now. I want you to call out 3 headings and scale them also. Don't select those ones that we selected. You know, the one we did now, we selected for this song and the age. Have you? So from this data, just select any random, not string or numbers. You can select the age, you can select followers, then you can select what? Discount, store it as a different data set. Then I want you to scale it to what? All the values under this mentioned header should be between what? 0 and 1, just like what we did now as your classwork, just to dissect this. The same thing. Yes. One.
Now, to check if the data is normalized, add describe. And you will notice that mean and mass are within 0 and 1. So this is just like additional way of confirming, because once you run the describe, remember that under data analysis, we're using the describe to summarize our data with basic statistical functions.
We are through writing that. Let me switch to other time. Can I switch? Okay. So all I need is just to add the Let me just add it here. I want to duplicate, describe. So you can see that if you check your minimum, it's between 0. Check your maximum, that should be between what? 1. So that is another way of confirming if you have actually normalized the data. Remember, we are still using normalization as one of the techniques for scaling. So now, in summary, that is how you can normalize with sklen. Now, the next one will be standardization. Remember, I said there are 2 ways. So let's see how we can achieve that same thing using standardization. So the difference will just be in different library usage. So the library we use there, the same sklen is involved, but the function you imported from sklen will be different from the one you are importing from sklen if you are considering standardization method of scaling. So what is standardization? Standardizations transform all columns to have mean of 0 and standard deviation of 1. So this is typically used when column contribution are normal or bell curve. So we are still using that same data set as our case study. Then here we are also importing, that is from the sklen dot processing, we are importing a different library, which is called standard scaler. Now here we created an object just like we did for normalization, and then we stored the function, the library, into that object. Then here we also did that, we use the object which is already holding the function to transform. So here I combine both of them together as dot fit and dot transform to become one, and then supply the name of your data set. Then here you pass in the calculated value into the read data frame, just like what we just did now. So, but for us to understand it, we'll not take them one after the other before we finally assemble them. Let's look at, so like we did the other time, let's start taking them one after the other. You are not writing the entire code that you copied before now. We are going to take it like this, just like we did first, to get the calculation ready before we input them into the data frame. So this is standardization. Methods of scaling. Scaling features. So I'll also start from, so let me just copy this line, just copy it, and change this to standard. Change this to standard scalar. Run it to confirm it. Now store it in store the imported data library in an object. So the name I'm giving std underscore scalar is equals to this. Let's see. Then here it has to appear as a function. I will run that as well to get output. So now that I've stored it as an object, then I will use the object to transform the data. So now use the object to transform the data. So I'll just call the name of the object std underscore scalar dot fits, then supply the name of the data, which is model underscore. Then run it. So answer derived. So the next thing is for me to, so we have executed that. Now, if I go back to the slide, then here now I want to describe it. See this one at all? Okay, yeah. So this is where we are now. Now here I want to describe it just to know what I have there already before calculating the variance, because here we are going to bring variance and standard deviation in here. So, but before that, let's get the describe of that same data set first. Just a verification. So let's say use comment. Let's us describe the data frame. Data frame. So I'll say model this dot describe. So I have this. Now here, let me reduce it. Now I increase it. So here we want to check for mean. Let's check for mean. Check for mean, and then we'll check for variance, because variance and the standard deviations are related, because standard deviation is the square root of what? Variance. So now let's get the mean using this formula, just like what we used the other time. The object name dot mean underscore. That will give us the average of each column. The average of each column. That is what we get. And then when you check for variance, then you also get what? The variance of each column. So let's run these two codes. So if I go back to, so the first one is Let's check for mean. Check for mean. Say std scalar dot mean underscore. So that is the average of each column. Now let's also check for variance. Also check for variance by also calling the name of the objects and concatenating var underscore. So we have it. Now we will now apply the transform, just like the way we did the other one, using just transform to calculate the number array of the value before we finally substitute them into the main data frame as our scale data. Okay, so now let's transform data to std model. Okay, so data is transformed. So you can see that the values we have under each of the column are now between 0 and 1 as well. But this is using standardization. So at the end of the day, it's not less for you when you have issue of not being able to work with certain values in a column, you can scale them to between range of numbers. So the next step will now be the next step will be to calculate the mean and the mean. So this is like the alternative method where you are using dot fits and what transform at the same time, just like what we did in the case of normalization. So I can skip this, but you can just write it down, still the same. Hmm?
To my notebook.
Okay. Okay. So now to perform all the calculation in one cell, just like what we did the other time, that is the code you have already written. So to calculate everything in one cell, not only that, at the same time, substitute the calculated value in their respective what? Header. So I believe we have written it before now from the beginning. Good. So let me just go and apply it. Now, so apply all calculation in one cell and also substitute the calculated value. Let's say values. Run. So I'll start by copying this, save this, and then add it here. So I'll also take where I store the library in an object. See? Then the next one is I'll create a variable standardize equals to, then take the formula. The last one I just apply, but in this case, since I did not apply that, so I'll take this. For your own case, I believe you use the one that have both fit and transform, right?
Right.
So that is what you copy. But in this case, I'm taking this because I skipped that very one in my own case here. Control C, then equate it with that. Then to frame it, I'll use pandas dot data frame, pandas dot data frame. Then the standardize, comma, volume. Equals to, specify the column, equals to the model, the data set, yes, which is subset, then dot column, yes, columns. If I run it, I hope there's no typographical error. This standard scalar instance is not that one that is. Let me. Did you try it like that? That no wonder you have the experience.
We must use it.
No wonder you have the experience. So the way she just shows that she have experience. So let me just say.
Read this one. I'm not using this one. Yeah, told me that last one.
It's safe to always use it.
Yes.
Instead of transforming by just doing the transform,
Yes, there's no need of doing this ones then. Yeah, just go straight to that, since that one is very important.
Yeah.
So now,
Fit underscore.
yes, fits fits on the store. So that is what I am supplying. Here. All right. Thank you for running ahead of us. All of us will have been debugging now. All right, so So let's also add that describe just to see if we will have the minimum within the range of what? 1 and 0 as well as final confirmation before the assignments. Okay, so finally, let's check if, let's check with describe. See, function. So I'll just copy this. See, paste, dots, describe. All right, so we are within the mean and mass is within -1 and +1, which means we have successfully standardized the data frame. So this is your assignment that we enable you to practice the feature scaling. So I have finally final request for you. We plan on cost clustering. So the next topic is going to be what? Clustering. That is where the modeling. Remember, I told us that this topic is the last topic under what? Data prep. So the next class now will start modeling data. And the method we are going to use for modeling data will be cluster. So we plan on clustering the data using distance-based algorithm. So the data needs to be scaled using the data frame with the 3 features for modeling. Can you scale the columns so that they all have a mean of what? 0 and a standard deviation of 1. Now, your key objectives, scale the features in the modeling data frame so they all have what? This. Save the output as final what? Data frame that is ready for modeling. Ready for modeling. So let me just, this is the assignment solution. Should we just go through it? No, take it as an assignment. Let me see what, let me just flash this so that you know the data we are working with. You see this data now. You know good. You have it in your notebook now. Good. So that is the data. Yes. Yes, you scale everything so that all the value under each of them will be between. So I just flash it so that you know the data you use.
Or we set up